Hello, learner. Welcome to this lesson. I'm your teacher, Mr. Okeyo. So let's start our lesson of today. So today we are going to discuss a topic in organic chemistry. And in this topic of organic chemistry, we will look at carbonyl compounds in organic chemistry. I'm sure in your previous module you did some chemistry, and I'm sure you have the knowledge of chemistry. So we will just build on what you already have. So today we are going to look at carbonyl compounds, just the way I've just said. So this will be doing by first these carbonyl compounds. I'm sure most of you are aware and know some of them. You did. And if I may ask a question before I start and continue, I want one of you to tell me at least 3 features or characteristics of any of carbonyl group. Yes, thank you for trial. So welcome to this presentation on carbonyl compounds, a fundamental topic in organic chemistry. In this session, we will explore their structure, properties, and reactivity with a focus on aldehydes and so let's now discuss aldehydes and the ketones. Remember at our beginning I said that we will only measure on aldehydes and ketones. Let's start with aldehydes. What are these aldehydes? Do you have any knowledge about aldehydes? What is this we call aldehydes? So aldehydes, so they compose of carbonyl group attached to at least one hydrogen atom. Carbonyl group attached to at least one hydrogen atom. Remember I said carbonyl group is bonded. It has the compound of a carbonyl group as carbon and oxygen bonded with a double bond. But here we are saying aldehydes as carbonyl group attached to at least one hydrogen atom. A good example of carbonyl group is formaldehyde. So formaldehyde has a structure of CH2O. So formaldehyde, this is what we call formalin. So I will make, if you have a question up to that level, you can ask. Or if you have anything to add. Yes, thank you for the addition. Ketones. Let's go to ketones. In ketones, carbonyl group bonded to two alkyl or aryl group. Example is acetone. So acetone is CH3COCH3. That's a structure, molecular structure of, in fact, that is a condensed structure of the ketone. So what are some of these physical properties of aldehydes and ketone. The first one is polarity. When we talk about polarity, when you talk about polarity, meaning they are polar. I mean that this compound, the aldehydes and the ketone, if you take aldehyde, any compound, for example, formaldehyde and acetone, they mix with water. They are polar in nature. Then another thing we'll discuss about the under physical, we also discuss the boiling points. Generally, the boiling points of the aldehydes and ketones are low. This is because their molecules are held by weak van der Waals forces. The van der Waals forces require less heat to break. Therefore, when these compounds are exposed to a little or limited source of heat, they attain their boiling point very fast. What about the solubility in water? Just because they are a polar compound, this compound tends to dissolve in water to form homogeneous solution. Here you can see some of the structures of the formaldehyde. You can see acetaldehyde and acet. Let's go to another subtopic. Reaction of carbonyl compounds. So carbonyl compounds normally undergoes up to around 4 type of reaction. The first type of reaction is called nucleophilic additional reaction. And in this reaction, it normally involves attacking. We have the attacking, you can see there's attacking from the back and attacking in the front. So involve just from the word nuclear. There's a reaction between, there's a nuclear reaction. Another part is oxidation. So aldehydes undergoes oxidation to form carboxylic acids. Then reduction. Carbonyl, so they go reduction to form alcohol. Remember, alcohol has a functional group of OH. Another reaction they undergo is called condensation reaction. They also undergo condensation. So carbonyl compounds are reactive due to partial positive charge on the carbon atom, making them susceptible to nuclear attack. So remember, nuclear addition reaction takes place due to the partial charges. So let's discuss another slide under application of carbonyl chemistry. So the carbonyl chemistry, this knowledge of carbonyl chemistry is used in the synthesis of drugs and fragrances. This is in pharmaceutical industries. Then another one is in metabolic pathways, e.g. in citric and circular. Then another application is industrial uses in polymer production. So it's also involved in the production of the polymer. Remember, polymers have a long chain, so the chain is long. So a good, like, additional, the additional reaction, the reaction continues to form a long chain, resulting to the polymer. Therefore, it is more significant in polymer production. So let me take this opportunity to ask if any of you has a question up to there. Yes, thank you. Yes, thank you for asking. That is an important question to address and touch more on this topic of carbonyl chemistry. So, in conclusion, so we have just discussed the importance, reactivity, and application of carbonyl compounds. Another one, encouragement to explore advanced topics in enolate chemistry. In summary, carbonyl compounds are versatile and central to many chemical and biological processes. Understanding their chemistry is key to advancing in organic chemistry. Thank you for allowing me to discuss with you about organic chemistry of carbonyl compounds. Thank you. Have a nice time.